Well, dry ice might be used to keep things cool, but there's a lot of fun things you can do with it too. And Jetpack Jason of Mad Science joins me to offer up some tips. First off, what is dry ice?
So dry ice is really, really cold, first of all. That's why they call it ice.
And it's so cold we have to wear gloves before we can handle it. You do not want to touch this with your bare hands.
Exactly. It's 102 degrees below Fahrenheit.
Oh my goodness.
Or 109 degrees below 0 Fahrenheit. There we go. Something like that.
It's only science.
Yeah, right? 109 degrees below 0 Fahrenheit is cold enough that it'll like cause almost instant frostbite on your fingers.
Like a burn or something on your finger, right?
It is. They call it a cryogenic burn. So yeah, you definitely don't want to be touching it with your bare hands.
Okay.
So we need to use gloves to use it. But to answer your question about what it is, it's frozen carbon dioxide.
Okay.
The same stuff that we breathe out. Yeah.
CO2.
Exactly. So you get it 109 degrees below 0 and you wind up with a chunk of frozen carbon dioxide. You know what? I'm going to reach past you here.
Oh my goodness.
Grab a giant one here because this is more fun to play with a giant one, of course.
And is it because
right?
it's so cold like that? That's why we kind of get that fog and that mist dropping off?
Right. What you see from this fog and this mist that you called it here is exactly that. It's like a cloud. It's condensation from all of the moisture in the air around us condensing on this cooler air here.
Oh.
And so we end up with kind of this cloud that's falling. Now, that's another really, really good observation. You notice it's not liquids dripping off of this, right?
Yeah, it's not like melting like an ice cube would.
Right. Normal ice cubes made out of water. But since this is made out of carbon dioxide, it's turning straight back into a gas.
Wow.
And so in science, we have a special word for that. It's called sublimation.
Oh, so that's when a solid goes straight back into a gas instead of solid to a liquid or a gas?
Exactly.
My high school chemistry is like totally coming back right now.
You got it. So with that property, some really, really fun things we can do. First, we can see just how, like, as it's turning into this gas, how much it actually expands.
Yeah.
So what we'll do, we'll take a little bit of this dry ice here. We're going to throw a little water in here.
Oh, so we have a beaker, some water, some dry ice.
Exactly.
Should I be covering my eyes here?
Yeah, maybe. You know, there's those there that
I need an excuse to put on these fantastic safety goggles.
Yes.
I don't know if you guys can see these at home here. Hold on. There we go. Guys, I'm ready for anything that Jetpack Jason's going to throw at me. All right, so we've got water in with that. Oh, look.
And then so you can see this dry ice right now is turning back into a gas really quick, right? So that's where our bubbles are coming from. These are awesome, Bill.
Hey,
and then,
you brought them, man. Maybe you should be wearing them.
But as this is turning into a gas, it's expanding.
Okay.
And you can see, like, that little bit is going to expand more than 500 times its volume.
Wow, look at it bubble like that. That's crazy.
Isn't it? Yeah. So there's other fun things we can do with this. Since it's expanding so much, you know, we're going to take this off of here so I don't end up with a popping balloon through the segment. They can get pretty scary. There's some other fun things we can do with this expansion thing. So I'm going to take this, but Bill, I'm going to have you grab a hold of that spatula there because it's a lot more fun. Now, I'm going to stick this on here.
Ah! It's crying.
Yeah, it is. And that's that gas expanding again really quickly. Now, you go ahead and put your spatula right on top of that.
Sounds like my alarm in the morning.
Right?
Or like, hey, hold on. It's for you.
I get
You get it?
Nice.
It's like an old school phone ringing?
Yeah.
Okay, sorry.
Like one of those that hang on the wall that nobody has anymore.
Do they still have those anymore?
I don't know.
Somebody get that. It might be the phone. Sorry. Okay.
Yeah, I tell you what we're going to do. We're going to add some more water here.
It looks like you have some food coloring in there.
Exactly,
What's happening here now?
Now, I just wanted to show you this really fast here. If we take the a piece of dry ice and we throw that in here, right, with our blue, notice our fog isn't turning blue.
Yeah.
And again, that's because it's all about the condensation of the moisture in the air condensing. It's not about this turning into the gas that we see.
Oh, I see what you're saying. So yeah, so obviously the water here is not what is causing that. It's the moisture that's inside the beaker that is above the water.
Exactly. Yes. Yeah, you got the science. That's it.
If you taught my chemistry class, I feel like I would have gotten A's instead of like C's.
I think you should teach your chemistry class.
Oh, no. If we get into chemical equations and stuff later on, we'll be way out of business.
Oh.
So first off, this stuff is really cool. Is this safe for kids to do at home? What should we need to know about this?
Under adult supervision. Definitely adults are the ones that should be messing with the dry ice.
Are you and I qualified adults for this?
Technically we are, but I'm not sure about really if we are.
Well, I think we're just about out of time here. So unfortunately, we can't see it. Well, real quick, do the...
Okay, I have to do this, Bill. I have to do it. All right, so we're going to add some soap to that, and that's going to catch
This is when things get really out of control.
Oh, yeah.
It's going to be fantastic.
All right, and then we're going to add some pieces here, maybe more. Stand back, put on the goggles, exactly, and come on, go!
Oh, look, there's some bubbles in it.
And there we go.
Oh, wow, that's crazy.
5.
Bubbles. Okay, here we go, up top. There we go.